Hey everyone, today we will be doing a GFG problem, which is basically the tree based problem, pre-order traversal. Basically, with the pre-order traversal name, we'll be coming to know we have to follow a particular traversal in a tree and we have to print the order. Okay, so basically, that pre-order means a particular type of traversal in which we first process the root, then left, and then right. So pre-order, just think it of like coming from the topmost. Okay, so first we'll encounter the root, then we'll go to the right, left, and then we'll go to the right part of the tree. Okay, so basically we'll just see the first example for now. Okay, now in this example tree is given, so how we'll be just traversing in a pre-order traversal. So first we have just encountered the root, so we'll print the root 1. Okay, then we'll go to the left part of it, then coming to this node, then again we'll just process the root node first, so 4 gets printed, and then again we'll go to root, and then we'll go to the left part, left, root over left will go, and then over here also root first, so root gets printed, and then again we'll go to the root is over, then we'll go to the left part, so left part is null, we'll return from here. Then root is over, left is over, then again we'll go to the right part, right is also over, so again we'll come to this root again. Okay, now coming to this root was over, left we have processed, and then we'll go to the right part of this node. Okay, right part of this node, coming to over here, we'll just print the root node first over here, that's why 2 gets printed, and then we'll go to the left part of it, it's null, so we'll immediately return. Then we'll go to the right part of this, again null, will return. And then since for this node we have processed the root, left and right, so this node is completed, all the traversal till this. Then again we'll go to the 1, then for 1 the root got we have processed, left part we have processed, then we'll go to the right part, since right is null, so we'll return to this, and thus our pre-ordered traversal is this. Okay, so 1442 is our pre-order traversal for this binary tree, for this tree traversal. Okay, now coming to this part, now after seeing the example 1, you can figure it out like how we'll be traversing in this. So first we'll process this root node. Okay, 6 gets printed, then we'll go to the left part of it, then left, after coming to here root gets printed 3. Okay, and then left part is nothing, then we'll come to the right part, 1 gets printed. Okay, then after this till here we have all processed, then again we'll go to the root, and then we'll again process the right part of this root. Okay, now coming to over here is first we'll go to process the root. Okay, so 2 gets printed over here, and then we'll go to the right part, left part of it, and here 2 gets printed, and coming to the left part of right, left is over, right part is come to the right part of this is null, so it will return. Since for this node we have already processed the left, root, sorry, for the first part we have processed the root, then we went to the left, and then we have already processed the right part, so it's returning over here. So again it's tree completion, has completed traversing all the nodes, so the pre-order traversal for this is 63122. So coming to the implementation part, we'll be using the Java program. So we'll see this in two parts. Okay, first will be the recursion, and the second will be the iterative. So in the interview also, if you will be asked, then you will be telling the recursive part first, and then if the interviewer tells to do it in a optimized way or not using recursion, so you will be doing in an iterative way. Okay, using the stack. So for the recursion part it's easy. Okay, because you have to just take care of the one call, and other parts of the call function it will automatically be taken care. So first what we have to just return, that first we have to create that thing. Okay, so array list will give the name as list. and new array list. Okay, and this we have to return this list only at the end, and the other thing recursion part will do in a separate function. So pre-order traversal. Okay, and then we will pass the root to it, and we will also pass the list because we have to store the values in it. And yes, again we will be in this recursion function. Will be defining pre-order traversal. Okay, pre-order traversal, and its mode, its root, and this is the array list. This is an array list of integers, and we can keep the same name. Okay, and we can also keep the different name. Okay, and if first of all, if we will check for the corner condition, if my root is null. Okay, so whenever my root was null, so I was just returning it. So here it will just return it. Okay, else we will go to we'll process the root first. Okay, pre-order, so root will come first. So processing the root means adding the value to the list. So root dot add list dot add root dot value. Okay, now here it's not value, it's data. Okay, okay, data will just add it to the list. Now root get processed. Okay, then we'll go to the left part of it. So again we'll call the same function okay, again we'll call the same function with where there is a root, we'll just call the root dot left part. Okay, root dot left part, and then second will be the list, same data structure. Okay, and again then after we for this node, after we have done with the root, after we have done with the left part, then again we'll go to the right part of it. Okay, so again we will be calling the root dot right part of it and this list. Okay, checking for all the test cases. Okay, it's taking a bit time. Okay, I made some mistake. Okay, where it is? Okay, here it should be capital I. Okay, function name, it's showing error. Pre-order traversal, it's same. Okay, now it's same. Okay, static and non-static. So since this is static, okay, so even this should also be static. Okay, now it will be running. Okay, now checking for other test cases, like for all the test cases should pass. So in order to consider this as a particular solution for this problem. Okay, yeah, all the test cases has passed. Now we'll be seeing the no, if the interviewer asks you not to use recursion, so at that time you have to be doing it with iterative. approach, and there you will be using a stack. So I'll be showing you that approach. So if my list, you have to return this, so you have to declare this, and here only we'll check the corner condition. If my root is equal to null, okay, if my root is equal to null, then you have to return the empty list over here, okay, and then we'll be declaring the stack. Okay, and the stack we'll be storing the root, so it will be of node and st, okay, and new, okay. Then first we have to process the root, then left, and then right. So we'll add it to the root, okay, we'll add the root. So st dot add push, okay, st dot push the root, okay, we have to push the root, and then we'll check if my, and then we'll go inside. If I have pushed the root, then we'll be processing, go inside the stack, pop it out, and then after popping out this element, we'll be processing the root, then we'll go to the left, then we'll go to the right. So we'll just check it. If my stack is empty, and it should not be empty over here, so we are giving not. So if my so first I'll be pushing out a root is equal to st dot pop, okay, just pop it, and list dot add root dot data, okay, root dot data, and then we will be moving to the left part and then to the right part. So but we are using a stack data structure over here. So in a stack data structure, whenever you will be pushing the left part first and then the right part, while popping it, right part will be processed first and then the left part would come. So we'll be pushing it in an opposite way. First we will push the right part and then we'll push the left part. Now, and before that we also have to check if it's not null. So root dot right, it's not null, okay, then just st dot push, okay, not push, we'll call this again, st dot push, it will be st dot push, okay, st dot push root dot right, okay, and if root dot left, okay, if root dot left is not equal to null, then st dot push root dot left, okay, root dot left, okay, and then ultimately we'll return the list, okay, return the list, okay, compile. Now checking for all the other test cases. Now it has also passed for this. Now the thing that you have to take care, like in a pre-order traversal using iterative, we have, since we are using a stack data structure, so we will be processing the right node first and then we'll going to the left part. So when we are popping out, so the right part will be at the bottom and left part will be at the top. So while popping out, the left part would come first and then the right part would have come, okay. So only this part you need to take care of, like, which is different from usual thing, okay. So in this video, till here we'll end our video, and Yeah, meeting you in next video with a different problem. Till then, thank you.